The next one is table mirroring table mirroring migration. So what this is basically you're writing the data from your source ingestion pipelines directly into both the original Hive table and the new Iceberg table simultaneously, right? So the idea here is that we're just going to have two duplicate pipelines that are running in parallel. The Hive table will have all the history plus the new data, while the Iceberg table only has the new data. Eventually, you want to backfill. So once you're done migrating everything into Iceberg, you then turn off the Hive table, and then, well, not turn off, but you stop ingesting into the Hive table, and then you go to the Iceberg table and you run a backfill job that takes all the history from the Hive table and write it into the new Iceberg table. And I'll show you a way to do it that's fairly safe. So some of the pros, no really impact to downstream or upstream users and applications. It's just another table. You can take your time and slowly move your writers and readers to this new table. If anything happens or breaks, move them back. Nothing goes away. It's fresh and up to date, so you always have the latest data. The complete Iceberg features are there like before. Performance optimization, cost savings are all there for the new data. Again, you're not touching the old data. So as the table grows over time, you can continue to get the optimizations of compaction and removing snapshots and things like that. Schema evolution, partition evolution is up to you. Can absolutely do it if you wanted to. Again, you're controlling that full pipeline. And of course, you can write into a different catalog. This is something I've seen. This approach is something I've seen fairly often. There's a good session recorded, and I can share that later. If you go to the Iceberg Summit that was hosted by Tabular back in early June. Actually, I don't know. A few weeks ago. There's some good recordings there. One of them has a specific example of of this pattern and how they use it, because it allows them to do a lot of testing and validation before they make the final commit and switch over to Iceberg. Some of the cons: we're duplicating data, we're running things in parallel. There is going to be additional compute resources. You're doing the same twice. If you have high volume of data coming in, now you're kind of doing it twice. There's patterns to solve that. One particular pattern what we are using at Absolver with a lot of our customers is that we take data from different sources into a staging table in S3. This can be a Hive Parquet table, this can be an Iceberg table. And then from that table, we basically create jobs that write into another Iceberg table, another Hive table, maybe into Snowflake, right? So you have a staging table, and then you basically just kind of copy the silver into the silver layer from there. And that gives you flexibility of, turning things off and on. Yes, like I said before, requires historical backfill. Not very hard to do, but it is something that you'll have to do. And if you have a very large table, it will take time and resources. But again, Iceberg makes it easy and safe to do it in case there's a failure or need to retry. Cool. So what does this actually look like? Just a high-level example. So on the left side, we have a bunch of connectors: S3, Kinesis, Kafka, Postgres. I'm showing you Absolver in the middle, but you can do it with Spark. You can do it with Flink, but it needs to be able to take in the source data and writing into two different targets, two different formats. So if you look at the Spark code that I have here, this is Spark code from Absolver, and you can see that we simply create a single job that copies from a MySQL database in this particular example, and then it writes it into a Hive catalog Hive table, and it creates all the Hive structure for you behind the scenes. And let's assume that's the original table. That's where all your users are. Now I'm creating a new job, right? I'm not changing the old job. I'm creating a new job that reads from the same source, right? In this case, it's MySQL, can be another S3 table. It can be the Hive table that you have here, and then be able to take that input and write it into a different catalog, different table, right? So now I'm running this in parallel, and I don't have an issue. Whenever I'm ready, I can cut over.